Hello everyone, welcome back to the GIS software video series. Today we're going to talk about some indices in GIS and show how to calculate them. So one of the indices is NDVI, which is used for quantify vegetation greenness. It basically shows a vegetation health, or we can identify a vegetation life from it. So how to calculate them? So the equation of the NDVI is NIR minus R divided by NIR plus R. NIR refers to the near infrared band and the R refers to the red band. So we know that a satellite image is consists of many multiple types of bands. So from them we can calculate their NDVI from them. So let's jump on it. Go to ArcMap, and here we will use some data. So if you here in the folder we can see some data here. So basically it is Landsat five different bands. So there are 7 bands in Landsat 5. So each of the you can see that each of the images. So basically for length different length satellite image has different NDVI formula. So if you go to the NDVI formula for Landsat 5, you can see that which is band 5 minus band 4 divided by band 5 divided plus band 4. So if you go to ArcMap, and we have the data of 4 and 5, so we add 4 and 5 data here. Yes, yes. So this is our required data, and now we'll calculate the NDVI from this formula. So we simply go to search, and here we'll search for raster calculator. This is it. Click on it, and here we have to put the formula. So we input the formula bracket band 5 minus band 4 divided by bracket band 5 plus band 4 bracket close. So this is our formula we inputted, and now we have to save it. We have the output folder here, and we'll save it in NDVI.tif. Hit save, and okay. So the raster calculating is executing. So the process has been done. So as you can see that the vegetation is red marked. So if we, this is the NDVI of the Landsat 5 images. If you go to its symbology and change the symbology, if you want to give the red to green, as you can see the vegetation can be seen here, and the rivers and barren land are differentiated. So that's how we can calculate NDVI from this. Now we'll calculate another index, which is the NBR. Basically, the NBR is used to identify burn areas. So if we calculate NBR of an area, we can see that which area is more burn or hot. So for Landsat 4 to 7, the NBR formula is band 4 minus band 7 divided by band 4 plus band 7. And for Landsat 8 to 9, the NBR formula is different, which is band 5 minus band 7 divided by band 5 plus band 7. So we did the NDVI in for landscape 5 images. So let's do NBR to Landsat 7 images. So if we add the data, here we can see the Landsat 9 image. If you click on it, you can see that different types of brand here. So we don't need all of them. We just need the band 7 and band 5. So we add on it. As you can see, the data is being added. It's taking some time. So as you can see, the data has been added. We don't need the previous files. So we untake it and focus on the Landsat 9 images, which is the band 5 and band 7. So now we have to calculate the NBR. Again, we have to go to the raster calculator, click on it, and now we have to put the formula, which is band 5 minus band 7 divided by band 5 plus band 7. So if you close it and if you save it in the arc.if and we hit save, okay. Now the raster calculator is executing the NBR. So as you can see, the NBR is calculated, but it is not being visually present. So if you go to its properties and go to the symbology, and if you change the color RAM, maybe blue to red, if you apply it, yeah, we can see that here the blue marks are seen and the red marks are can be seen. So the red marks are higher values, so it is more burned according to the blue area. So that's how we can calculate NBR from a Landsat 9 satellite image. That's how we can calculate different types of indices from satellite images. Now we'll see another thing. So if we untick this, all of this, and we have to uh, remove all the files, and we'll add a new data, which is from new folder Landsat 5 images band 1. If you add it, yes. So this is band 1 images, and if you want to a mask a portion of an image from this band, we have to select that portion. We go to the folder connection. Now in this output, we're gonna create a new shapefile, which is mask, and we'll give the feature price to polygon, and the position will be BTM. Okay, close. And now the new shapefile is created. We have to change its visibility. So we'll increase the width and the border red. So the mask is created. Now we'll start editing the mask. So now if we select the mask and go to create feature and we'll select the rectangle. So we'll mask this portion only. So we'll select this and stop editing. We'll save it. So we have to put the mask this portion from this band. So if you go to search, and here we'll search extract by mask. There it is. We select on it, and if you input the raster, and if you input the mask, and the output will be, let's say, mask.pif. Save and okay. So the mask has been created. If you untick this, you can see only this portion of it. But if you want to take all the mask from all the band images of Landsat 5, we have to do it by continuously, which is very time consuming. So what we are gonna do? We are gonna build a model so that all the mask can be, the image can be taken. So if you go to this model builder, so this is the model builder of ArcGIS. So if you want to take the mask from these images, we have to make a model. So if we untick this and remove this, and now we will input the mask. So what we need is a iteration model, which will help to mask the images from the images. So if we go here and from insert, if we add iteration, sorry, iteration, and select the rasters. So this is it. This is the iteration model, and we need the mask toolbox from the art toolbox. So we will take this and drag it to here, and now we'll connect this iteration to the mask toolbox. So this is the connect option. So we select this and take the mask. We'll input the raster. So the connection has been completed, and now we have to give the iteration the file. So a workspace, the all the band images are saved. So if you go to the catalog, raster catalog, folder connection, here is the this new folder. In this new folder, all the 7 image band of the Lancet 5 images are taken. So we select this folder and add it here, and hit OK. So it has been done, and now we have to put the shapefile here. So we will put the mask shapefile here, and we'll also connect the shapefile to the mask and input the mask data. So the model has been built, but there are still some job to do. We auto layout this and if we select folder, and now this is the we have to select the output folder. So if you go here, and this is the output folder, but if you want to name the output band of our images, so we have to name exact the same name of the file. We have to name the output as percentage name percentage. We hit save and we hit OK. So it has been done, but to visualize it, we have to right click on the name and we click on the add to display to see all the images here. So this is the run button. If you run it, the process has been running. So as you can see in the background, all the output images are being added here. So the model has been run successfully. So if you close the first band, we can see the different image masking images of all band. So untick it, you can see the all mask has been completed. So that's how you can create a mask or create a model by any toolbox. So that's how we can make a model. So this is it. That's for all today. Thank you everyone.